Chapter 6, Lesson 1, Ratios. So a ratio, the definition is a comparison of two quantities by division. So ratio is just a way that we can compare two different things, two different quantities of something. So there's three different ways that we can write a ratio. We can write a ratio 3 to 9. We can write it as 3 to 9, and we can write it as 3 to 9 as a fraction. This is the most common way that we see it written as a fraction, but we read all of them like this first way is how we read it. We read it as 3 to 9. Okay? When we talk about writing a ratio in its simplest form, it's like a fraction. So the two numbers cannot have any common denominator or any common factors. When we look at those two, we want to say, is there anything that can divide into both of them? We do not write it as a mixed number. So it can be in improper fractions, no decimals. But it's just a fraction that we simplify as small as we can get for the numbers. Okay, so if I was going to write some ratios, if I say 12 baskets and 18 attempts, I would write it, I'm going to write all of these as fractions. I would write it as 12 to 18, but then I need to simplify that, and I say 6 can go into both of them, so it's 2 to 3. And we can put those units if we went with it. 2 baskets to 3 attempts. But we don't have to, since this was what our original ratio was given to us. We always assume that the first number goes with baskets and the second goes with attempts. Okay? And I'm going to go down 36 out of 84 DVDs. So I'm going to say 36 to 84. I'm going to say, okay, well, those numbers are both even, so that's an easy one. I know it's 18 out of 42. They're still even, 9 out of 21. And then I say they can both divide by 3, and I get 3 to 7 as my final ratio. 10 out of every 30 people own an iPod. 10 to 30, they can both be divided by 10, so 1 to 3. 24 out of 60, so 24 to 60, and I can simplify that. They can both be divided by 2, so 12 to 30. They can both be divided by 2 again, 6 to 15, and they can both be divided by 3, so 2 to 5 is my final ratio. Okay? When I talk about ratios involving measurement, there's something important that I need to remember, that both quantities must have the same unit. If they don't, I have to change them before I can simplify. So they must have the same unit. So if I write a ratio, I don't write it as like feet compared to inches. I need to compare inches to inches. So if I have some examples, 2 pounds to 6 ounces. So I say, okay, so 2 pounds to 6 ounces. Well, I need to change that. And we always change the unit that's bigger. So pounds is bigger. So I'm going to say, well, there's 16 pounds in 1 ounce. So in 2 pounds, there's going to be 32 ounces to 6 ounces. And now I can write it as 32 to 6. And then I'm going to simplify that, divide them both by 2, and I get 16 to 3 as my final ratio. So the next one, I have 9 inches to 1 yard. So 9 inches to 1 yard. So I'm going to change that yard into inches. So I have 9 inches, and 1 yard is 3 feet, and each of those feet is 12 inches, so 36 inches. So then I have 9 to 36, which I can simplify, divide them both by 9, and I get 1 to 4. 6 gallons to 3 quarts. There's 4 quarts in 1 gallon, so in 6 gallons, there's 24 quarts to 3 quarts. So my ratio is 24 to 3, and my ratio is 8 to 1. Now this one, it's important that we don't just write it as 8. Keep it as 8 to 1. In a ratio, you always want to have both numbers. And then I have 3 pints to 4 quarts, and there are 2 pints in each of those quarts, so 3 pints to 8 quarts. My ratio is 3 to 8, and it cannot be simplified, so that's my final ratio. Okay, units of measure that you need to know. We just looked at some of them. In each gallon, there are 4 quarts. In 1 pint, there are 2 cups. In 1 quart, there are 2 pints. And in 1 cup, there are 8 fluid ounces. So those are units and measure that might be a little bit unfamiliar to you, but units and measure that you do need to know.